Hey guys, some of you had some questions on a few of the problems on today's arithmetic sequence practice worksheet. So I wanted to make a quick video to show you a few extra examples to help you get through. Now in today's lesson, you were basically using two different rules for arithmetic sequences. This is the rule to write a formula for your arithmetic sequence, that a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. And then the formula above here is the sum formula, where we're finding the sum of some number of terms, and we do that by taking n divided by 2, where n represents the number of terms, and multiply that by the quantity of a sub 1, which is your first term, plus a sub n, which is your last term. So when we're working through most of the sum problems, we're really going to focus in on this first formula, but we're going to see that we might every once in a while need to use that second formula as well for these. All right. Now, as we're going through these problems, we're going to look at different scenarios where maybe you know the first and the last number and you have to figure out how many terms there are, or maybe you know the first number and how many terms there are and you need to figure out the last number. Those are the kind of possible scenarios we're going to be looking at. So in my first two examples, we actually know what our numbers are, and so we have to figure out how many terms there are. Now, when they say to find the sum of the first however many positive integers, so in this case, I chose 35. So find the sum of the first 35 positive integers. If you think about what integers are, those are our positive whole numbers. So when we're starting with the first 35 of them, we're starting with the first number we would see, which would be 1. And then our integers increase by 1 every time. So we would get 1, 2, 3, 4, all the way up to, for this problem, 35. Now I could sit there and look at a number line and count them all, but when I'm trying to figure out how many integers are between two values, there's a quick way that we can find the total number. To find the number of terms or the number of terms in between two integers, you subtract your ending value minus your starting value, and then you add 1. All right. So if I were to look at this problem, my ending value was 35, my starting value was 1. So I would do 35 minus 1 plus 1 and find out my number of terms here was 35. And if you think about it, that makes sense. If we're counting out the numbers from 1 to 35, we're going to count 35 of those numbers there. So now that I know what my n is, and I know what a sub 1 is, that was my first term, and I know what a sub n is, that's my last term, I'm ready to go ahead and drop those numbers into the formula and solve. So for this problem right here, we know n is 35, so we're finding the sum of the first 35 positive integers. And so we're going to take 35 divided by 2, and then in parentheses put a sub 1 plus a sub n. So my first and my last number, so in this case, 1 plus 35. That's going to give me 35 divided by 2 multiplied by 36. And so if you go off to your calculator and do the math, you're going to find out that this gives you a total of 630. All right. So anytime they're asking you for the sum of however many integers, as long as you're saying the positive integers, you're starting with 1 because that's our first positive number, and then you're counting up to whatever value they tell you to stop at. And then to get the number of terms, you're just going to take your last value minus your first value and then add 1, and that'll get you your n value. All right. So similar things happening in this next problem. Again, they're telling me to find the sum of the integers from -4 to 8. Now, again, integers create an arithmetic sequence because they constantly increase by 1 every time. So again, if I were to think about this list, I would be taking -4 plus -3 plus -2 plus -1 plus 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. I could expand this all out if I want. But really what I know is that this right here is my first term. This guy over here is my last term. And then I could expand it and count out to find out there were 13 terms, or I could use that new fancy rule. To find my number of terms, I take my last number minus my first number and then add 1. So 8 minus -4 plus 1 would tell me there were 13 terms in this sequence. And if you count this up, you'll find out there were, yes, 13 numbers there. So now I can go ahead. I know my a sub 1, I know my a sub n, I know how many terms I have, so I'm ready to go ahead and use my sum formula. So the sum of the first 13 terms would be 13 divided by 2. And then a sub 1 plus a sub n would be negative 4 plus 8. Negative 4 plus 8 is positive 4. And then 13 halves times 4 would give me 26. Oops. So the sum of my 13 integers in that sequence there would be 26. Now, in these two examples, we were given integers, so we knew they were an arithmetic sequence because integers are those positive whole numbers, so they constantly increase by positive 1 as we move up the number line. But we can use this partial sum formula for any arithmetic sequence. It doesn't always have to increase by 1. So sometimes you might have to figure out the sequence yourself, and then that will help you determine what your a sub n is. So for this last example here, they want me to find the nth partial sum for the given arithmetic sequence. So they started out by telling me a few terms in my sequence, and then instead of expanding it all the way to the end, they told me that eventually after we expand this out, we should get 12 terms. So for this problem, we know our n value. We want 12 terms. We know our a sub 1 value because they gave me the list and they started with 5.5. But what I don't know is a sub n. So in these types of problems, that's where this rule is going to come in handy. I'm going to write the rule for the sequence, and then I'm going to find the specific value they want me to find. So to find a sub n, we start with a sub 1. In this problem, that 5.5. And then we add on in parentheses n minus 1 times d, where d represents that common difference. So to find our common difference, all we have to do is figure out how is our pattern changing. You can find out by taking the difference of two consecutive terms. So for this one, I'm going to take my second term minus my first term. So I'm going to do 5.1 minus 5.5 and find out my common difference was negative 0.4. And I can see that makes sense. My pattern's going down by 0.4 every time, so that's why my difference is a negative 0.4. Once I have my rule for a sub n, that's going to allow me to find any term in that sequence, as long as I know what term I want. So for this problem, I don't care about the stuff in between. I just care about that last value I'm going to get once I hit that 12th term. So we're going to finish this up by finding a sub 12 by just replacing 12 for n into this formula right here. Oops, I wrote a plus sign instead of a decimal. So we want to do 5 plus 5 plus 12 minus 1 times negative 0.4. That's going to give me 5.5 plus 11 times negative 0.4. And if you go to your calculator and do the math for that, you're going to find out that this is 1.1. So now we have our first value was 5.5. And in this case there, that's our a sub n. That's our last value. And we knew that our n was 12. So to finish up, to find the sum of these 12 numbers that would be generated in this specific sequence, we're going to take 12 divided by 2, take our starting value that they gave us of 5.5, and add in that last value that we found using our formula of 1.1. It's going to give me 12 divided by 2 times 6.6. And if we do that math, we're going to get 39.6 for the sum of those 12 numbers. All right. So notice that this pattern wasn't integers. There wasn't actually a difference of negative 0.4 in between these, but that's okay. The formula still works. You just need to be able to know how many terms you want. So you need to know your n value, your starting value, and your ending value. And with those three key pieces of information, you can go ahead and use your sum formula. All right. Let me know if you still have any questions.